Continuing on our discussion, we're going to now talk about chemical changes. What is a chemical change? A chemical change forms a new substance that is different than the two substances being mixed together. The new substance is made of the same elements as the original substances, but are now in different combinations. The key characteristic is the production of new materials that are chemically different from the starting materials. Chemical reactions are mostly irreversible to get the same exact substances. However, we do find that there are some reactions that are reversible, like in your blood. There's a reaction where the blood will change and reverse to keep the pH of your blood to be stable based upon how much carbon dioxide and carbonic acid is present in your blood. It keeps you alive. So now we're going to look at a bunch of evidences of chemical changes. If we see these things, if we can observe these evidences when different substances are reacting and mixing together, then we know that a chemical change or a chemical reaction has occurred. Now you'll notice that sometimes I say chemical change, sometimes I say chemical reaction. They're interchangeable. You can use them because they both mean the same thing. So our first evidence of a chemical reaction is when we notice a color change. That's often a sign that a chemical change has occurred. For example, when the leaves change in the fall, which is going to start happening pretty soon. If not, maybe you've already observed that in your neighborhood within the last week or so. This is a change that cannot be reversed. Another evidence of a chemical change is precipitation, or a new solid forming. For example, in this picture, you can see that these two clear solutions, this one in the beaker, this one in the test tube, when mixed, form a yellow precipitate. Precipitate means a new solid, but it also can sometimes be a liquid as well. This is proof that some kind of new substance has formed. We also see a color change. Along with forming a new solid or a new liquid, also a new gas or gas production as a new substance is an evidence of a chemical change. In a reaction called photosynthesis, which happens in plants every day, oxygen is formed and released from the leaves of the plants. This oxygen is a byproduct of the reaction between carbon dioxide, which is in the atmosphere, and water, which the plant brings up from its roots. Also, the plant is able to form glucose, which is another product. So here, in this case of photosynthesis, both a new gas and a new solid is produced in the chemical change photosynthesis. One of the unfortunate evidences, but one that you'll know very well, is a change in odor. So oftentimes, if something smells bad, smells like it's rotting, then you know a chemical change has also occurred. Like when the food spoils, or an egg rots, or if your bread starts to go moldy, that's showing that a chemical change is happening in those foods. Heat released is another form and sign of a chemical reaction. So natural gas, methane, is burned, and this chemical reaction creates heat. This is how a gas stove works, but usually in your home you might be using propane, you might be using methane. It just depends on what kind of gas hookup your family might have. But that heat from the burning of the gas is being released out into the atmosphere. So when things burn or combust, a lot of heat is released, and that's another evidence or sign of a chemical change. Continuing on with that idea, so a change in heat, light, or sound will indicate that a chemical change has occurred, like the explosion of fireworks. Heat will be given off or can be also taken in. You can see that also when you strike a match. The potassium striking will generate a lot of heat and combust. Keep in mind that chemical changes take place as energy is being added or taken away, and we'll look more into that later. Another sign of a chemical change can be that of bubbles or foaming that happen during reaction. A great example of this is washing your hands every day. The soap and water mixed to foam and bubble in order to trap the bacteria and dirt on your skin's surface. My favorite evidence of a chemical change is a new yummy taste that can also identify that a chemical reaction has occurred. So think about when you're making brownies or cakes, or like we can see here, these muffins. It's going to taste a lot different than the solids and liquid that you use to combine to make your yummy treat. However, remember that some foods that we cook are just combinations, and their ingredients maintain their flavors and physical state, like a fruit or vegetable salad. In that case, those are not chemical changes because all of the little ingredients still taste the same, even though you've kind of mixed them all together. When we look at chemical reactions involving atmospheric oxygen, they have to have that oxygen present for the reaction to occur. Like fires. Fires always need oxygen to burn. Or in the case of copper and iron, that rusting reaction is because oxygen, or O2, which is its chemical formula, is in the presence of the water or the air. Sometimes you can have chemical changes that affect physical properties, like when you cook an egg. The physical properties of an egg being liquid, its color, its texture, will change after the chemical reaction has occurred. So after we've cooked the egg, it's solid. It might still be a little bit runny in the yolk, but for the most part, everything is now solid. The texture is a lot more rubbery, or if you scrambled them, okay, they're kind of light and fluffy versus kind of that sticky, runny, liquid texture that you see when it's a raw egg. Again, looking at rusting, that also will change physical properties because of its appearance. Now the metal is showing that it's being oxidized. It has that rust color, and you can tell that the metal is no longer shiny. The main take-home point is that chemical changes can and most often change the physical properties, because when they mix with another substance, we're creating a new substance that has different physical properties than what its two combining parts had individually before they mixed. And just to kind of compare the difference between physical and chemical changes, physical changes only affect physical properties, whereas chemical changes will affect both physical and chemical properties. In the case of both a physical change and a chemical change, we see that they require or release heat energy. So both of them need energy to happen. And we can usually see that change in heat energy through temperature, whether the temperature increases or decreases. Physical changes produce no new substances. It's still the same material. The atoms are just arranged differently in a solid, liquid, or gas state. Whereas in a chemical change, something new is being produced, and the atoms rearrange to form new molecules. Physical changes are generally easy to reverse, whereas chemical changes are generally irreversible.